Hello, and welcome to Lockheed Martin Fort Worth. I'd like to take the opportunity to talk to you about the F-35 Lightning II, fifth generation fighter. Now, when people hear fifth generation, they normally think stealth or VLO, very low observable. But really, fifth generation is a combination of not only stealth, but sensor fusion. Now, stealth is comprised of basically two pillars. One is the geometry. So as we go around, and I'm pointing out different aspects, I'd like to call your attention to the geometry, the angles that are common. You'll also notice that the horizontal stabs are in line with the wings, so they're kind of obscured. If you had the capability to look down the intakes, you wouldn't be able to see the face of the engine. All of this combined with the coating is what provides that stealth. Now, stealth is not just radar, it's also masking IR capability as well as visual signature. So when we talk stealth, we're talking about the entire package. The other thing I mentioned was sensor fusion. Sensor fusion is a generational leap that uses kind of a feedback engine to control all of the sensors. What sensor fusion brings to the fight, or to the pilot specifically, is it controls the sensors and determines what sensor is needed or best suited to track which target, and then combines that into a nice succinct image of the battlefield so that the pilot has the capability to make those battlefield decisions as required. Now, two sensors that I'll talk about right here are the T-FLIR and our DAS camera. That system together comprises our electro-optical targeting system, or EOS. We'll start off with the T-FLIR, or the forward-looking infrared sensor. It is typically on a fourth-gen aircraft a pod. However, with the F-35, it is integrated into the aircraft, as you can see. It provides targeting capability, as well as getting imagery from far away. It has a laser for targeting, as well as a laser spot tracker, so that we can use off-board lasers to guide our weapons in. The DAS, or displayed aperture system, is 6 cameras surrounded around the aircraft that give the pilot that 360-degree field of view, and that's projected on the helmet, which we'll talk about more later. What DAS brings to the pilot is a new capability. So again, when I was flying that fourth-gen fighter, I was always checking behind me, looking out for unobserved threats, specifically those infrared threats, heat-seeking missiles that could be fired either from another aircraft or from a land-based or a ground-based station. The only way when I was flying my fourth-gen fighter that I knew something was coming up at me was to visually pick it up. What DAS brings to the pilot is it's an additional sensor that will detect the missile plume and alert the pilot to it. Next, we'll talk about the weapons that the F-35 can bring to the fight. We'll start off with the internal gun. F-35A has an internal 25mm gun. The fact that it is internal to the airframe means that we don't compromise our stealth capability. We have 2 weapon bays. Each weapon bay is capable of carrying up to a 2,000-pound class warhead, as well as an air-to-air missile in each bay. Alternatively, we can carry 2 air-to-air weapons in each bay for a total of 4 air-to-air weapons, depending on how you want to configure the aircraft. Under the wing, we have 3 weapon stations, an inboard, a midboard, and an outboard station. The inboard and midboard station are configured for air-to-surface weapons and have been cleared to carry up to 2,000-pound class warheads. The inboard station does have the growth capacity to carry up to a 5,000-pound class warhead. The outboard station is configured for an air-to-air missile only, and at this time we have the AIM-9 heat-seeking missile cleared to fly on that station. Taking a step back here, we have the IPP, or Integrated Power Package. It's similar to an APU or auxiliary power unit that you would have on your 4th gen fighters. However, it is completely automated. So from the time that pilot turns it on, it's run by the vehicle management computers, the VMCs. When the pilot first turns it on, it will provide electric power to start the engine. Once the engine is started, it will then transition to what we call a bleed mode. So it will take bleed air and use bleed air to provide the motive force for the IPP. The IPP then becomes an integrated part for the cooling system of the aircraft. The benefit of it being completely automated is it adds to the survivability. The reason I say it adds or enhances the survivability is if the aircraft takes damage, the IPP will automatically transition modes to keep the aircraft in the safest state possible, so the pilot never has to worry about it. Further back here, we have this white antenna. This is one of our MATL antennas. MATL is a data link that allows F-35s to communicate amongst each other. The beautiful thing about MATL is whatever I'm seeing in my aircraft, I am able to share with every other F-35 out there. Additionally, MATL is not just a data link to share information, it allows us to enhance the capability of the F-35. So if I'm out there flying as a single ship, one F-35, I have a certain level of capability. If I have two F-35s out there, 1 + 1 is now greater than 2 because of MATL. In addition to MATL, the F-35 also has Link 16, so we're able to take the tremendous amount of situational awareness, or SA, that we have and share it with every other platform, both airborne, land-based, and sea-based, that has Link 16 capability. This allows not only the pilot to make those immediate battlefield decisions, but it also allows that information to be shared with the battlefield commanders so they're able to direct as required. It's powered by the F-135 Pratt & Whitney engine that is rated at 40,000 pounds of thrust in full afterburner. Very high, highly reliable engine with dual FADEC capability. The F-35A carries about 18,000 pounds of fuel internal. Compared to when I was flying fourth gen fighters, the legacy F-18 carries a little over 10,000 pounds, and the Super Hornet carries a little over 12,000 pounds internal. Why is this important? Because with the single engine and that much fuel on board, my on-station time is greater. If I'm flying a max endurance, max range type of profile, I'm able to get 2.5 hours of on-station time easily out of this aircraft. Here we have the Gen 3 helmet. It is considered to be an integrated part of the aircraft and an additional sensor for the pilot to use when they're executing their mission. The helmet has two visors. This inner visor, which is used to capture the projected imagery from two projectors, so a binocular technology versus monocular. All of the flight critical information and tactical information is projected onto the visor. You have an outer visor that acts as a glare shield only. 3 tracking systems are integrated into the helmet: a magnetic tracking system, an inertial tracking system, as well as a visual tracking system. These tracking systems, along with all the other sensors integrated into the aircraft, ensure that the pilot has 100% confidence the weapon will go where it needs to. Finally, there's 2 cameras integrated into the helmet. One is for mission playback. It captures exactly where and what the pilot is looking at, as well as the symbology that is projected on the visor. Finally, there's the night vision camera that allows the pilot to project that night vision camera image onto the visor, as well as the DAS imagery that we talked about earlier. Now, this is important because when I was flying 4th gen, when we had to put on night vision camera, I either had to fly with a JHEMIX, where I then lost symbology to trade it for night vision, and then you had the added workload of trying to put the bracket on at night as well as attach and detach those goggles as required. I hope that you've enjoyed this discussion about the F-35. Thank you.